Hi girls, as requested, I'm going to make you a circles revision video and I'm trying to keep it as short as I can. The first thing I want to remind you is that you'll need to be able to label the parts of a circle, possibly draw them or maybe even explain them in your own words. So please go through our notes and those definitions and make sure you understand them. The next thing you'll need to know is your rules for finding the circumference of a circle, so the length around the outside as well as the area of a circle. The circumference of a circle is 2 pi r, and if you remember, the 2 lots of the radius is the diameter, so we can also use pi d. It doesn't matter which rule you use, just make sure you know your rules. Area of a circle, we use pi r squared. Now for a sector, which is this slice of pie we've got over here, that's only part of the circumference that we'll be finding. So if we're looking at the actual circumference or the actual arc length, so if I asked you to find that arc length or even the perimeter of this full sector, so the perimeter of the full sector, we'd have r plus another r, so that would be 2r, and then we don't want this part of the circumference, we only want this part here, and the fraction of the circumference we have is theta on 360 times 2 pi r. So that would be the full rule that we'd start with if we were finding the perimeter of a sector. To find the area of a sector, once again, we don't want pi r squared, we want a fraction of the area. So we're going to times by the fraction of the circle we have, which is theta on 360. So that theta, that angle inside the sector, is very important. Let's start with a basic example on finding the perimeter and the circumference and the area of a circle. So circumference is 2 pi r or pi d. Pi d probably would have been better in this circumstance, but that's okay. So we've got, actually no, we will do pi d. It doesn't make sense to do 2 pi r if you have the diameter. So pi times d, and that's pi times 5.2, which is the same as 5.2 pi. That's an exact form. Okay, so if it's an exact form, I'd put 5.2 meters and I'd say exact form. And that's because if I put pi into my calculator, my answer will not be exact anymore. My calculator will round it. So if I do put this into my calculator, it gives me 16.3 meters, and I'll put 1 dp. We can now go and find the area, and for that we'll use the formula pi r squared. And we need to know that if that's the diameter, the radius will be that quantity divided by 2, which is 2.6. So we're going to times by 2.6 squared. So be careful not to use the diameter if you're supposed to be using the radius. Now if I put the 2.6 squared into my calculator, I'll get 6.76 pi, and that's if I'm looking at doing exact form. So that would be 6.76 pi square meters in exact form. But if I put that in my calculator, it'll give me 21.2 square meters to 1 dp. So quite basic examples, and that's the setting out that I would expect you to mirror. Hi, next we're going to find the perimeter and the area of a sector. And here's my sector. That angle there, if you can't see, is 150 degrees. And we have a radius here of 12 centimeters. So to remind you, we need to start first with our rule, which is if I want the perimeter, I'm going to walk along here and along here, which is really 2 lots of the radius. And then I'm going to need that angle because I need to know what fraction of the circumference I want. And then I'll times it by 2 pi r. From there, I'm going to substitute in the radius, which I will change to 12, my theta, which I will change to 150 on 360, and I'll times by 2 times pi times the radius, which is 12. And this is where I will start to put things into my calculator. See if I can change my colour. Firstly, I'm going to tidy the 2 times 12. I'm also going to tidy the 150 on 360 times by 2 times by 12. So you've got to enter things into your calculator carefully. We know 2 times 12, that's easy. That's 24. Next I'm going to put in one go, 150 on 360 times 2 times 12. And if you do that, you will get 10. Then the pi needs to drop down as well, and we get 24 plus 10 pi. That would be in the units of centimetres, and that is in exact form, okay, because I'm leaving it with the pi there. It's quite a nice, tidy little expression. I think we'll stop at exact form, actually. We'll just leave it like that. You can do the calculator work too if the question asks you to. If we're finding the area, and have a slightly different rule, okay, I'm going to be doing pi r squared, but I don't want the full circle. I want only a fraction of the circle. So start off with your basic rule. I'm going to put in our angle for theta over 360 times pi times 12 squared. And this is where we want to enter certain parts now into our calculator. All the numbers, everything except for pi. Pi is also a number. Just don't enter the pi if you're doing the exact form. So if you put all of that into your calculator, you should find, at least I found, that I got 60. And then your pi should just drop straight down, and it is area, so it's going to be square centimetres in exact form. So those are two slightly more complex examples, but we have the same process, which is set out a rule or the formula, substitute, and then tidy. Okay, don't forget to give your units and tell me about your answer, if you've rounded it or is it in exact form. All right, working backwards questions. For this question, I've told you the area, but you have to find me the diameter. So we know the area of a circle is pi r squared. So I will replace the area with what I've been told, which is that the area is 15.7 square meters, and I'm trying to solve for r. So now it becomes an equation where we have to make r the subject. The first thing I'm going to move is the pi. There's not much else to move. There's a squared and a pi, but the squared has to go last because it's attached to the r. So I'm going to divide, because there's a time sign here, I want to do the opposite, and I'm going to divide by pi on both sides, and then this pi and that pi will cancel, leaving me just with my r squared. So I get r squared equals 15.7 on pi. Now I need to get rid of the squared, and I can do that by square rooting. Now I'm hoping at this point you remember that when you take the square root of an equation with the squared, you need a plus minus. But in this case, we're not going to put the plus minus, we're going to say as the radius is positive. So I don't even need to worry about whether it's negative, because I know the radius of a circle is positive, but I really should explain myself, which is what I do here. So we'll just write r equals the positive square root of 15.7 on pi, as r is positive, and we know that the diameter is actually 2 lots of the radius, which is this expression here. I don't need to use my calculator till the very, very end, and if I wanted to, I could type that into my calculator, and it actually gives me 4.47 meters to 2 dp. But just notice I only used my calculator right at the end. So that's a good example of a working backwards question. Lastly, I've got a challenge problem for you. You can, through these videos, you can pause them at any point in time, try and do the questions, and then check your solution with mine. And that's what I recommend you do for this nice little challenge question. I'm asking you to find the shaded area, and I want you to do it in exact form, okay? In exact form. So let's see how you go. Pause the video now if you're going to give it a go. I hope you will. And I'm going to go through the solution. We can see here that I've given you the radius of this bigger circle and the radius of the smaller circle. So I might extend it and draw in the fact that that would also be 3 and that would also be 2. So it means that the diameter of this big circle here is actually 10, which means its radius is 5. Okay. So I've got 3 circles, a big one, then a medium one, and a smallest one. It's like the 3 bears. I think I've been reading fairy tales to my children too much. So what we're going to do to find the area is we're going to take the first circle, we might even call that capital R, and then I'm going to minus this circle and this circle. I'm going to minus pi little r 1, r1 all squared, meaning radius 1, and I'm going to minus pi times r2 all squared. And really, if I'm going to use language like that, I really should label what is what. So here, I'm going to call that r1 equals 3, and I'm going to say that r2 equals 2. Okay? So I want to make sure I'm nice and clear with what's what in my solution. So we're going to start off with the big circle, and we worked out that its diameter was 10, its radius is therefore 5, so we'll substitute in pi times 5 squared, minus, now we're going to look at the next circle, which has a radius of 3, so we're going to do pi times 3 squared, and then we're going to minus lastly the smaller circle, which has a radius of 2. That's pi times 2 squared. And then we're going to simplify. 5 squared is 25, so we get 25 pi. 3 squared is 9, so we get 9 pi. And 2 squared is 4, so we get 4 pi. And then I can subtract. If I've got 25 pi's and I take away 9 pi, that will give me 16 pi, so 25 minus 9. And I take away another 4, and I would get 12 pi. And that is exact form. Because they didn't give me centimetres or metres or any other units, I just write units or square units. Okay? And this is in exact. The only thing I want to remind you before this video ends is that please, if you decide to go and use a certain notation in your questions, just make sure that you label it. So I haven't really got capital R labelled on my diagram, but I'll leave that off. Which I should have called that capital R there. But please label, so R1, R2, and if you want to, you can always put a line here, and you can say capital R equals 5. But the clearer your work, the better for whoever has to read your solution. Good luck with your study, and I hope this video helps you get ready.